For this first example for how to construct confidence intervals around sample proportions in Excel, I've got data from the General Social Survey from the year 2016, where respondents were asked the question, do you think that the use of marijuana should be made legal or not? And there are two response options I reported here, that being respondents who indicate it should be made legal, and those who indicate that it should not be made legal. As we can see here, about 61% of the sample offered the should response as compared to about 39% that offered the should not response. So let's go about now constructing a confidence interval around the sample proportion of should responses. What we're going to do here, first of all, is to compute the proportion of respondents that offered the should response. So I'll take the frequency of the should response and divide it then by the total number of cases, and that's going to be what we'll call p hat referring to the estimate of the population proportion offering should based upon the sample. Now our next step in this process will be to compute the standard error. For a binomial response variable such as this, as I indicated on the slide before this, the way in which we construct the compute the standard error is we'll take the percent or proportion of responses, always in proportion, of offering should, multiply that by 1 minus that number, and that represents the proportion that do not offer should. And then what we'll do, I'll just put those in brackets as well, since that would be the numerator. And then we'll divide it then by the total sample size and hit return. Now keep in mind there's one less step that we have to go through, and that is we now have to take the square root of this entire value. And now we have a standard error of 0.011. The next step here is to determine the confidence level, and what I'll do is just use the standard 95% confidence level, so anywhere from between 0 and 100 rather, but typical values are going to be 95, 90, and 99. And the next step now will then be to identify the probability value or the alpha value that's associated with a confidence level of 95%. Now what this is going to be here, is going to be the area under the curve that falls outside the 95% confidence level, or in other words 5%. Now we don't express it as a percent, instead we'll express it as a proportion. So in order to find the probability value or the alpha value in this instance for the 95% confidence level, I'm going to take 1 minus, and now I'm going to put in parentheses the confidence level divided by 100. Now the reason why I'm dividing it by 100 is to get into a proportion. And what we should see here, if we've done this properly, it should be a value of 0.05. So in the event that I change it to instead the 90% confidence level, the result now should be 0.10 for the probability value, and it is. Or if I go to the 99% confidence level, the result should be 0.01 for the alpha value, which it is. Let's go back to the 95% confidence level as a standard for us. Now what we need to do is define what critical values are associated with the 0.05 alpha level. To do so, we're going to use the norm.s.inverse function in Excel. The norm.s.inverse function returns the z-score value below which a given proportion of the area under the standard normal curve falls. So using the Excel formula, let's put in equal norm.s.inverse. The norm alludes to the normal distribution. The S refers to the standard normal distribution. So in that case, a mean of 0 and a standard deviation of 1. Open parenthesis. Now we'll identify the probability that we want to use. And let's put in 0.95. It's going to be between 0 and 1 for the probability, and hit return. Now when we do this, you notice the result here is a value of 1.64. What this indicates is that a 0.95 proportion of the area under the curve falls below or to the left of a z-score of 1.64. Conversely, 0.05 proportion of the area under the curve falls above or to the right of a z-score of 1.64. And it is this area to the right of the z-score that comprises the alpha area of 0.05. But because we are constructing a confidence interval, half of the probability value indicated by the alpha level should be in the extreme positive or right tail of the normal curve, and half should be in the extreme negative or left tail of this curve. To find the z-score value that sets off the most extreme positive 0.025 proportion, or 2.5%, of the area under the normal curve, we divide the value of alpha by 2 and subtract from 1. This is then the critical value of z, a positive critical value of z. So in other words, what we're going to do here is enter into this formula 1 minus, click on the cell that contains the probability value, and divide that by 2. And now we see that the critical values of z will be plus and minus 1.96. Now the next step is then to use the critical value and compute the margin of error. So we'll take 1.96 and multiply it by the standard error. So equal 1.96 times 0.011 and hit return. And there we see our margin of error is 0.022. Now we have all the information we need to actually construct then the confidence interval. So what I'm going to do is take the actual p-hat value, 0.611, the proportion in the sample that responded should, and to find the lower limit, I'll subtract from that then the margin of error of 0.022. To find the upper limit of this confidence interval, I'm going to take again p-hat, and this time I'm going to add the margin of error to it. And that's what we have now is our confidence interval. Now oftentimes what you'll see is the confidence intervals are presented as percents, not as proportions, but whenever we do our computation we must transform this information into proportion format. So to just take our p-hat as well as the lower and upper limit and instead report them as percents, I'm just going to do nothing more than take that value and then I will multiply that by 100 to put it into a percent. And I can just autofill this formula down, and we see then that our confidence interval will range from 58.9% up to 63.3%. Now the margin of error oftentimes is reported as a percent, and that's how I tend to report as a percent. So I'm going to do the same thing here now for the margin of error of 0.022 and just multiply it by 100. And so there you have the margin of error is plus or minus 2.2%, and then we see the lower and upper limits of this confidence interval. For the second example of how to construct confidence intervals around sample proportions in Excel, I've got data from the Marquette University Law School poll that was conducted October 26th through 31st in 2016, just before the presidential election. And it's a survey of likely voters, 1,189 likely voters, that is. Individuals were asked via telephone, if the election for president were held tomorrow, for whom would you vote? And then the four main candidates were listed off: Clinton, Trump, Johnson, and also Jill Stein. What we're going to do here is construct the confidence interval around support for Hillary Clinton. To do that, first of all, let's construct the proportion of the sample who indicated they would vote for Clinton if the election were held today. So equal the frequency that indicated they would support Clinton sample size. And there we have a proportion of 0.458, and we're going to construct our confidence interval around that proportion. Now what we'll do in this example is we're going to rely upon the typical assumptions for reporting public opinion polls, and there are two main ones. One is that the confidence level that is used for constructing confidence intervals for these sorts of poll results is the 95% level, and also the standard error computation, we assume that the proportion in the population from which this sample was drawn actually has 50% support, in this case for Clinton, and 50% that do not. So we won't use the sample proportion for constructing this standard error. So let me go ahead and construct the standard error equal, and we'll use the formula we had before, but instead of using the sample proportion for constructing the confidence interval for the standard error, we'll use 0.5 proportion, assumption of 50-50 split 4 and not 4 in the population, times 1 minus 0.5, and of course then we'll divide that by the total sample size. Now that's the heart of the equation. What I have to do though is take the square root of that, so I'll put the entire equation then in parentheses for the square root, and there we see the standard error is 0.015. Now the reason why a 50-50 split is used for constructing this confidence interval, the standard error rather for this confidence interval, is that it gives us the largest possible standard error mathematically given this sample size. In that case, the widest confidence intervals, hence the most conservative estimation of what the population support is for this particular option based upon this sample. Now, for the confidence interval, or level rather, we'll type in 95, the 95% confidence level, and just like we did before, the probability value or the alpha level, it's going to be equal to 1 minus, and in parentheses, we'll take the confidence level and divide it by 100. The reason why we divide it by 100 is we want that in a proportion. The probability value should be a proportion. In this case, it is 0.05. Now, to find the critical values associated with the alpha of 0.05 or a 95% confidence level, keep in mind that it's a two-tailed test we're always using, or two tails for our confidence interval, so we'll have two critical values. I'll put equal norm.s.inv, inv for inverse, minus, or rather in parentheses, 1 minus, and now I'll take G2 divided by 2. And we call G2 is we take the probability value, the alpha, half goes in one upper tail, half goes in the other, a lower tail. Hit return, and we see our critical values of 1.96. Now for the margin of error, that's going to be equal to nothing more than our critical values times the standard error of 0.015, and there we see our margin of error is 0.025. Now we can construct our confidence interval. For the lower limit, I'll take equal the proportion in the sample that support that option, subtract from that then the margin of error, and then I'll do the same thing for the upper confidence limit, the support for that candidate, but I'm going to add the margin of error. And there we see the confidence interval ranges from 0.429 up to 0.486. So based upon the sample that we observed, where 0.458 indicate they would vote for Clinton if the election were held today, we can, based upon the 95% confidence level, suggest that the population from which this sample was drawn likely ranges from 0.429 proportion support for Clinton versus 0.486 proportion support for Clinton. Oftentimes, though, you'll see this information will be reported in a percent, not a proportion. So let's go ahead and convert our information to percents from proportion. So equal, and I'll take the proportion support for Clinton and multiply that by 100. Now if I just click and autofill that down, we'll see then that automatically we'll take then the lower limit and multiply it by 100, and then the upper limit and multiply it by 100. So it ranges from 45.8% up to 48.6%. The margin of error often is reported as a percent, so I'm going to take our margin error we computed and multiply it by 100. And there we have margin of error plus or minus 2.8%. So this is the information we would then report for this particular confidence interval. Now for this last example, I'm going to continue with the example I worked with in example number 2 here. And now I'm going to construct the confidence interval for Donald Trump. So click on the cell underneath the heading Donald Trump, but across from support for, in this case, P hat or Donald Trump. So equal, click on the cell that has the frequency count for the number that indicate they would support Trump if the election were held today, divided by the total sample size, and there we see 0.395 proportion of the sample would support Trump if the election were held today. Construct the lower limit for our confidence interval, equal, take our sample proportion, subtract from that the margin of error, and we'll do the same thing for the upper limit. Now this time though we add the margin of error to our sample proportion, and there we see the sample ranges from 0.367 up to 0.424 for our confidence interval. We're going to convert these now into percent, since that's how we tend to report them. And what this indicates here then, based upon our observed sample of 1,189 likely voters in Wisconsin this week or so before the election, 39.5% indicate they would vote for Trump if the election were held today. Based upon that observed sample proportion and the 95% confidence level, we would indicate then that that sample probably came from a population that ranges anywhere from 36.7% support for Trump up to 42.4% for Trump. Now I'm also going to take the margin of error and convert that to percents by multiplying it by 100. So we see the margin of error reported twice. Now what I'd like to do is show you how you can take these confidence intervals and actually graphically present them. So what I'm going to do is click and drag then to highlight the two values for our two sample estimates, that being 45.8% support for Clinton and 39.5% support for Trump. Come up under Insert, come over to the tab for the bar charts, and I'll choose the very first one, a simple bar chart. Now let me go ahead and move it to its own sheet so we can make it a little larger to work with. Now what I'm going to do, so this is a bar indicating the proportion in our sample or percent that would support Clinton. This is the bar representing the proportion, or the percent rather, in the sample that would support Trump. I'm going to come over to Design, click on Chart Element. I'll add an element here, and I'm going to add error bars. Now I'm going to come down to the More Error Bars option and make sure that both directions are chosen. We want to have a positive and a negative error bar. And I'm going to come down to Custom. This is where we indicate how much should our bar be, above or below the sample estimate. So I'm going to click on Specify Value, and the first, for a positive error bar, how much do we add above the sample estimate for our confidence interval? Click on this little tab, come over to where the information is that we're constructing the chart based on. It's here in this particular sheet, and I'm going to click on and drag. So we have to have 2.8% for each of our candidates. Click back on that little icon. Now click on the little spreadsheet icon, and it will select the same information again for the negative bar. Click back here, and now click OK. And let me go ahead and close this so you can see it a little larger. And now we have our confidence intervals have been added to our sample estimates. I've already gone ahead and created this particular chart and formatted a little bit. And this is a way in which then we can report visually or graphically what these confidence intervals actually look like.